Hello, and welcome to a guide on how to solve the Magic Square puzzle in Pokemon Reborn. This puzzle is known as one of the hardest puzzles in the game, and it is not required to beat the game, but you get some sweet items out of it, and it is a necessary step to get the second to last department store sticker if you don't use the internet. In this video, I'm gonna go over not just the solution for the puzzle, but the thinking process behind how I would solve the puzzle. And this strategy is based on a strategy guide that I found on the Reborn forums. I put a link to it in the description. I highly recommend checking it out if you're interested. So, to start the puzzle, you need to have completed the events at the glass workstation first, because in there you get the meteor card. Once you do that, you can return to the North Obsidia ward, and if you re-enter that building where you fought that Magnezone, you can swipe the ID card, and that opens a new room. So, jump in, we go down here, and to start the puzzle, we just talk to this computer, and it'll explain the rules. So, rules. Move the numbers between each screen. Each line through the center on both 3x3 grids must add up to 15. Careful to pay attention to the word choice here, through the center. So we only care about the center horizontal line, the center vertical line, and the two diagonals on each grid. The lines count horizontally, vertically, and diagonally, and except the center, no two numbers can be in the same position on both sides. So, begin. And from my understanding, there are two versions of this puzzle, and I believe one of them is, I believe the versions are dependent on who was abducted at Belrose Manse way back when. I believe this is the version you get if someone other than Saphira were abducted. And so you would, in that case, you would get this if either you fought the doctor back at Urayu headquarters, or if you didn't fight the doctor, you blocked Sirius during the meteor attack on Belrose Manse. So the first step to solving this would be to first, you want the 5s in the center. So row 2, right, so we have this 5 on the left side in the center. And for the right side, you would, in order to not mess up this 5, you would want to bring it left first and then down. Next, usually what I'd like to do is make sure that there are no duplicate numbers on each given grid. And the reasoning behind that is, in the final solution, typically you would have one of each number on each side. So if you look at the left board, we have 2 9s and 2 1s. And we're missing a 3 and we're missing a 7. So we need to get rid of one of the 9s, one of the 1s, and we need to get a 3 and we need to get a 7. So first, let's replace one of the 9s with a 7 on this side. Specifically, let's replace the 9 in the top left corner with the 7 on the right center here. And to do that, first move row 1 to the left. That slides 9 to this side. It wraps around, and we can slide column 3 up to replace that 9 with this 7, and then slide row 1 back, and we completed this substitution. And I'm going to use the same trick to replace this 1 with that 3. You take this 1 on the top right corner and this 3 on the left side, and swap them, essentially. Well, not exactly swap, but move that 3 to the top right, to where that 1 is. So we want to move row 1 to the right, so that 1 is in the same column as the 3 we want to replace it with. Then we move column 1 up to replace that, and then slide row 1 back. And now that we've completed those substitutions, there is 1 of each number on each grid. So then afterward, I like to go left to right, column by column, to solve. And the first column, we don't need to do anything, because the requirements of adding to 15 only involve lines that go through the center, and the column 1 does not go through the center, so we don't care what that adds up to. So column 1 is all set. Now for column 2, we got lucky, because 6 plus 4 plus 5 equals 15. So column 2 is also solved. Now for column 3, we have to look at the corresponding tile in column 1 to determine what goes where. Specifically, what we want the number in column 3 and the number across from the center 5 in column 1 to add up to 10. That way, if you include the center 5, the sum is 15. Because we have a 7 in the top left corner, that means we want a 3 in the bottom right corner, because 7 plus 3 equals 10. Because 9's in the center on the left side, we want a 1 in the center on the right side. Because 2 is in the bottom left corner, we want an 8 in the top right corner. So let's get the 8 in position first. So to do that, we just slide column 3 up. And then we want a 1 here and a 3 here, and lucky enough, those are correct. So now the left side of this is completely solved. Now we just gotta solve the right side. And the process for solving the right side is pretty similar, except there are a few subtleties we need to be aware of. First of all, the left side is solved now, so we don't want to mess with what's already solved. Second, with the exception of the center 5s, we have to make sure that the numbers on the right side are not in the same positions as the numbers on the left side. For example, because we have a 2 in our solution on the bottom left corner, we do not want a 2 on the bottom left corner on the right side, otherwise the solution would not be correct. Also, an additional thing I'm going to do that's not required to solve the puzzle, but does make things easier, is because we have a 2 on the bottom left corner, I want to have a 2 on the bottom right corner on the right side. Basically, whatever number is in the solution on the bottom left corner on the bottom left side, or on the bottom left corner on the left side, we want to shoot for having the same number in the bottom right corner on the right side. The reasoning behind this is so if we're ever in a situation where we just have to swap 2 numbers on the right side, there is a simple algorithm that we could use that depends on this being true to swap those 2 numbers. So, okay, so we want the 2 on the bottom right corner, but I like going left to right. So that means in the solution, we need an 8 in the top left corner to make 8 plus 5 plus 2 equal to 15. So to move 8 to the top left, this 8's gotta replace that 2 there. So if I just slide row 1 to the right 2 slots, I accidentally selected row 2. Oops. So row 1 to the right again. So I moved row 1 to the right 2 spots. Then I moved column 3 up to replace that 2 with the 8, and then move row 1 back. So now 8 is in the right spot. And 6 and 1, they are fine, they don't conflict with anything. So let's just go with that for now. And for column 2, we're lucky again, because 7 plus 3 plus 5 equals 15. That's already solved. So, woohoo! And at the end, the third column, we just have to make sure that the number here and the number across from the 5 in column 1 add up to 10. And let's solve the top right corner first. So because there's a 1 in the bottom left corner, we want a 9 in the top right corner. So to get that there, we just have to slide column 3 up. And this is what I was talking about with the 2 in the left here. Now, the only thing stopping us from solving the puzzle is the 2 and the 4 are swapped from where they need to be. Because 6 plus 5 plus 4 is 15, and 8 plus 5 plus 2 is 15. All we gotta do is swap these. So we just follow the algorithm for swapping, which is row 3 left, column 3 down, row 3 right, column 3 up. And now we have a solution. And our prize is a Darkinium Z, a TM for Thunderbolt, and a Gardevoirite. And if you look at the numbers that have a lighter color, and put them together, you get 139749. To get the second to last department store sticker, you would have to go to that random house in a gate and tell the lady this password, and that would open a secret room and you would get the sticker. And as I mentioned earlier, there is a second version of the puzzle, and I'm playing this from a different save file where Saphira is the one who was abducted at Belrose Manse. And to trigger that, you would need to refuse to fight the Doctor at Urayu headquarters, so you fight Sirius instead, and then during Team Meteor's attack on Belrose Manse, you need to block the Doctor. Those would get Saphira to be the one who's abducted, and this would result in a different puzzle. It's the same rules, and the numbers are in different spots. So I'll just use the same strategy I did for the first puzzle. First, let's make sure we have 5s in the center. So we just slide row 3 to the right and slide column 2 up. We got a 5 in the center on the left side. And to do that on the right side, move row 1 left and move column 2 down. Next, we want to make sure that we don't have any duplicates on either side. And if we just focus on the grid on the left, we see we have an extra 4 and we're missing an 8. So we want to replace one of these 4s with an 8 from the other side. And what I'm going to do is I'm going to replace the 4 on the top right corner with the 8 on the left middle 8. So to do that, I'm going to slide row 1 to the right, so the 4 and the 8 we're replacing it with are in the same column. Then slide column 1 up to complete that substitution, and then slide row 1 back. And now we have a board with a unique number where every number on each side is unique. Next, we'll go left to right, column 1. We don't need to worry about anything because there aren't any rules for what they add up to. Next, column 2. We need this column to add up to 15. Currently, 9 plus 2 plus 5 is not equal to 15, so we need to make some changes. We have 2 options. We could put a 1 at the bottom, or so we get 9 plus 5 plus 1, or we could put an 8 at the top, so we get 8 plus 5 plus 2. And I prefer putting an 8 at the top just because the 1's already on the left side and we already declared that solved, and I prefer not messing with that. So to move the 8 left 1 tile without messing too many other things up, this is a little bit difficult because they're in the same row. So first I would move column 3 down to make them not in the same row. Then I can move row 1 to the right, so the 9 and the 8 that the 9 is replacing, or is being replaced with, are in the same column. So then I just slide that column up, so the 8 takes the spot where the 9 was, and then move row 1 back to the left. And now column 2 is solved. 8 plus 5 plus 2 equals 15. Next, we want to make column 3 correspond to whatever numbers are in column 1. So because 3 is in the top left, we want a 7 on the bottom right, 1's on the left, we want a 9 on the right, and 6 is on the bottom left, so we want a 4 on the bottom right. So let's solve the 4 first to get 4, because 6 is on the bottom left. To get 4 on the top right, we just got to slide column 3 up. And then 1 and 9, 3 and 7, they both happen to be already in the spot. So now the left board is completely solved. Let's move on to the right side. Again, in order for the algorithm of switching 2 numbers to work in the event that we need to, because in our solution we have a 6 at the bottom left corner, we want our desired solution to have a 6 in the bottom right corner. And so if we go work left to right, if 6 is supposed to be in the bottom right corner, we need 4 to be in the top left corner. So now it's just a simple matter of sliding column 1 up. And now and I don't see a problem with 7 or 8 being there, so let's move on to column 2. Our two options are to put a 7 at the bottom, so 3 plus 5 plus 7 is 15, or put an 8 at the top, so 8 plus 5 plus 2 is 15. The problem, though, is that we already have an 8 at the top and a 2 on the left, or 2 on the bottom on the left side, and we can't repeat positions of numbers between boards except for the center 5. So 8, 5, and 2 is not an option. So the only option we have is to put 3 and 7. So we have to move the 7 to where the 2 is. So do that, just slide row 3 to the left, slide column 1 down, so the 7 is replacing that 2, and then slide row 3 back to the right, and then there's the additional step of sliding column 1 back because we do care about where the 4 is. So now the second column is solved. But now we've introduced a problem in the first column. Because 8 and 2 add up to 10, ideally we want those to be on opposite sides of the 5. So to have one of them in column 1 and one of them in column 3. So this wouldn't really fly. And the easiest way I see we could do that is to just move this 8 out of the way to where this 1 is. So let's slide row 3 to the left, let's slide column 1 down, slide row 3 back, and slide row column 1 back up. So the 4 is still in the top left corner, and now this looks good. Now let's solve the last column. Let's start with solving the top right corner. So we have a 1 in the bottom left corner, so we need to have a 9 in the top right corner. So all we need to do is move column 3 up, and the other 2 are already in their solved position, so we are now done. And same passcode 139749 and same items. I hope this video was helpful. If you want to see any other puzzle done out, feel free to leave a comment. Thanks for watching.